Thanks everyone for joining today. My name is Dennis and I create software products for about 20 years. And last 10 years I do it in test automation field. And currently I'm in love with Ropes, a test automation tool that we develop at Inflectra. So we are doing very interesting and awesome things. You can follow me on Twitter and send questions by mail. You are very welcome. So let's start our webinar. Today, I'm going to talk about manual testing, automated testing, differences between them. So this is the first webinar in our series, Automation Demystified. So I'll be posing a lot of questions and I'll just start answering some of them. What is UI test automation? Why do it? Who can do it? What should be automated? I'm a big fan of walking and driving, and I see a lot in common between these activities and testing. Walking is a great way of getting from point A to point B, and you are moving slow enough, you can look around and notice things around you, and there is no need for any paved roads, and you don't need fuel for your vehicle, and you can even carry some things with you. In other words, walking gives you big freedom and choosing direction, but a bit limits your speed and the number of things you can take with you. But everything really changes if movement is automated. Using a car, you can get to point B faster and take more things with you. But is it so simple and straightforward? If you use a car in a big city, as I do, you may get stuck in a traffic jam. So remember that lucky man leaving you behind in a couple of traffic lights in a row. So while you are sitting in your car waiting for the green light. Did you ever notice anything with wonder by walking in a place where you used to be driving every day for a long time? Did you ever get to destination much later than you planned because of road blocks or detour that you have to take? On the other side, we often choose some kind of transport commuting to work or back home. So on average, it allows us to reach destination much faster than on foot. And if it's a public transportation, we have time to do other things. We can do things we love. We can even watch videos or write text or do something creative. So let's now just replace walking with manual testing and using a vehicle with test automation. And we'll get a very similar picture. First, there is no universal best choice. Second, there are different tools, vehicles that help you achieving goals. And third, automating things requires certain skills. So let's sort this out. I will start from the manual testing. There are two types of manual testing. When a tester follows a predefined script, when every step is defined, we call it scripted testing. So the script tells what to do with the application under test step by step, what data to input, and what result to expect. So here is a simple test. You can see on the screen, this test checks math in calculator, and every step is clearly defined. A person executing this test knows exactly what data to input at every step and how to determine that the system behaves and responds correctly. So this is the scripted testing. Since every step is defined in advance, a scripted test can be developed and executed by different people. In some cases, such a test maybe good candidate for automation. So automation engineer implements a test and the software tool runs it. So returning to our analogy to walking and driving, if we have a working car, there are good roads, and we know how to drive, why not to reach point B faster? So if we can automate something and it's easy, so let's do it. Okay, on another scale, another side of the scale, it is exploratory testing. This is the second type of manual testing. The shortest definition of it is simultaneous learning, test design, and test execution. So when you do an exploratory testing, you do not have a script in advance. So you generate the steps based on goals and observations you make during testing. And all steps, you document all the steps along the way to ensure that if you will find something interesting, it can be reproduced later. So a couple of examples of exploratory testing. Let's take university exams. So when a teacher poses questions to a student during an exam, so this is definitely an exploratory testing. Next question that professor teacher asks, to some extent, depends on previous answers student made and on initial plan of the teacher. So let's compare oral exam and written exam. And written test more resembles the scripted testing. Another example is testing of application store submissions, like iOS App Store or any other application store. So you get an app, and as a tester, you have a rough idea of what this application should do, and you need to test it and make a decision, either it is ready for publishing or not. So you make assumptions, you check them, and you decide if application output is valid. So this is definitely an exploratory testing, and you don't know in advance how you will do this testing. So we are now getting closer to the main topic of our webinar, UI test automation. So, and I think that it's convenient to split automated end-to-end tests or UI tests into three types. So, scripted testing, automated scripted testing. This is the most common type. So, the sequence of steps that could be performed manually is automated. So, during test execution, a software robot interacts with an application like a real user, inputs data, clicks buttons, and verifies output. All is done automatically. So the test on the slide that you can see is checking application login screen. So it enters the username, you can see it on line 4. It enters the password, you can see it on line 5. Presses login button, and then there are a couple of assertions when this test just checks that logout and login operations were successful. So scripted automated testing is very much like commuting to work or back home. So this is a routine, and if it can be automated, then this is good. So this we can free up our time to do more creative things. Automated exploratory testing. So imagine a software tool that given a website URL and a brief description of the purpose of this website can figure out everything that it needs to do testing, performs the testing and reports the issues. So this is something not really possible today. And And this is the subject of current research activities. So possibly someday, AI-powered robots will be able to do exploratory testing. At this point, there is no any evidence that in foreseeable future, robots will replace humans in QA. So, and at the end of the day, exploratory testing is more like going on foot. You are moving slow enough, you can notice various aspects of application behavior, and things that are okay for an automated test may be easily detected or maybe even not possible to perform by a human. So let's look at a couple of examples. So here we have an example of UI testing playground site that we specially created to challenge test automation tools to see how they can deal with some specific issues in applications. So this is the artificial example where we have two overlapping buttons. One of them is blue and another is green. And what's interesting for software robot, there is no any issue to click on the green button that you don't see. It's not possible for human, but for automated test, this is not a problem, but it can be a problem for test execution. So we can do something that nobody can do. What's wrong here on this website? This page is functional. There are edit boxes, buttons, links, and if you will run automated test, it will be able to perfectly enter the data, press buttons, click links, but there is really a problem with this website. If you do manual exploratory testing, you notice this without any issues. Okay, so let's move to the next type of automated testing. There is also generative approach to test automation. So, and one may consider it as the first step to automated exploratory testing. And there are two big movements in these fields. I will start with model-based testing. This type of testing involves both manual and automation efforts. First, you have to build manually a machine-readable model of the application. So usually it is a state machine, so you describe states and transitions between them. And second, a machine algorithm reads the model and generates test cases automatically. So on this picture, you can see a very simple model. And one of the biggest challenges in model-based testing is selection of test cases from the pool of generated test cases. Even for this very simple model that shows the login procedure for the website, for a sample application, the number of generated test cases is pretty big. So there is a problem of selecting what test cases to execute. So doing UI test automation, this is a slow process. Every UI test is executed pretty slowly. And if you will execute every test, then you will get nothing. It will be too slow. Another type of generative automated testing is fuzz or monkey testing. So this is about a software tool interacting with the application in a random way and frequently using invalid data. So the tool tries to input invalid data, randomly click buttons, links, and so on, and the application should not crash, and it should somehow respond in a reasonable way. So this type of testing is pretty well developed, and there are tools that perform this type of testing. So But most widely used type of UI test automation is scripted test automation. And we'll be talking about it in this and our next webinars. So frequently, it is automation of manual test cases. The main reason of it is people really want to offload boring and repeatable tasks to machines. And this is where the first roadblock usually hit. Test automation does not come for granted. It costs time and money, and this should be done really wisely. If time and resources that you spend on development and maintenance of automated tests are less than resources spent on manual test execution, then go for it, go for automation. But otherwise, think what you're doing wrong. So if you don't see a benefit, then you are really doing something wrong. Don't do automation just for the sake of automation. It must be really driven by business objectives. So let's look at the ideal curve of performance of a QA group starting doing test automation. So you should expect a slowdown at the beginning of the test automation project. So the reason of that is you really need time to understand what can be automated, how to do automation, and what tools to use. With time, you should reach the next level of performance. So machines will be running your automated tests, and you will have time to either create more automated tests or do more of manual exploratory testing. What are the differences between manual and automated testing? What makes them so different types of testing? So there are things that in test automation that have much more impact on the process than in case of manual testing. What is very easy for human may be very, very difficult for a machine, so and vice versa. Further on, we'll talk about such things as identification of elements within application under test, maintenance of automated tests, flaky tests, and of course, data-driven testing. Most automation tools deal with the hierarchy of elements within an application. And it may be pretty hard to identify an element, and it may be pretty hard to interact with the element. So you may need to learn tools and develop test automation skills. So here is the screenshot of the web spy displaying document object tree of a web page. So if you are doing web testing, you will get familiar with that. To find an element, an automation tool usually remembers during recording, remembers various information about the element and the DOM tree itself. But sometimes a tool may need assistance to reliably identify an element. And this is where you may need understanding of some technical stuff. So you may need understanding of nodes, attributes, locators, XPath, and some other technologies used to build the application you are testing. And automated tests need maintenance. So updates to application UI or underlying technology may just break things. Let's compare these two versions of the login screen to a sample application. If we have a manual test for login, check-in, if we have a manual test, it will not change at all after switching to a new technology used to build the application. So on the left, we have an old version of the application, and on the right, we have React-based version of the same application. Manual test will not change. It's not because it's not hard for manual tester to find new username and password fields. This is very easy for human, but it may be a problem for an automated test, and it may require you to do update and fixing the test. Flaky tests. So this is the completely new experience for those who just start doing test automation. Flaky means that a specific test may just fail from time to time. It may pass or fail. So on Monday it passes, on Wednesday it does not pass, and on Saturday it passes again. And also it can be the number of tests in a test set that fail or pass from time to time. And this number of tests in this group that is flaky, it can be different tests every time. So why it happens? It happens because modern applications just they load data over network, and data may be loaded with different speed. This speed depends on server, it depends on network performance, and also sometimes servers may not return data that we need, just do not respond as we require or expect, and it leads to some uncertainty in page loading. It is not a problem for manual testing, but it really complicates test automation. Imagine a situation when a button is displayed on screen, a robot automated test clicks it, but the application at this point did not finish initialization yet, and thus does not respond to this button click. How do you determine that application did not respond? In most cases, it is not a problem for manual tester, but requires an automated test to be able to do such things as wait, retry, and recover. Wait means that the test should wait long enough for UI element to appear on screen and be ready for interaction. Retry means that in some cases, repeating interaction may advance test execution. So when you do manual testing, you click on a button. If nothing happens, you just click second time and maybe it works. And recover means appropriate reaction to some unexpected pop-ups, error, and warning messages. So like you are doing testing, some message pops up, you should close it to continue execution of your test scenario. So these are flaky tests. Let's now talk about very positive thing about automated testing. One of the biggest advantages of test automation is opportunity to run same test with different input data at almost no additional cost. So computer time is cheap, and if you parameterize the test and feed it with a table of data, you can get significant benefits compared to manual test execution. So on this screenshot, we see a test that gets username and password from the table defined in this test as well. So on lines 5 and 6 and 7, we have some data, usernames and passwords. And on lines 12 and 13, the test just passes the data from this table to the application. Doing test automation requires skills. Non-programming testers can do test automation to a certain level of complexity. There are cases when record and playback of automated tests is a viable and sufficient approach. So if you plan, however, to get most of test automation, it is very beneficial to have some skills. So I would list here algorithmic thinking, so ability to clearly define test steps of your test case and understand about conditions and loops. Also, you should have understanding of technologies used to build a system on the test. So like the DOM tree and an XPath that I showed in one of the previous slides. And what is most important, you should have at least very, very basic knowledge of any programming language. So it doesn't matter what the programming language is, but if you know at least any programming language, it will let you to progress much more effectively and get much more results from test automation. So wrapping up, set to this point. Manual and automated testing, really not something mutually exclusive. These types of testing complement each other. So test automation may and should save time for exploratory testing. It is not possible to automate everything or anything. What is easy for a human may still be very, very hard for a machine. So, and vice versa. A computer, as it was said in one of the testing books, so can do the work of 3 million mathematicians using sticks and sand, but fail to click on a button within the application. So do test automation wisely and beware Rube Goldberg machines. So don't overcomplicate things and choose the best approach for every scenario. So either manual or automated, whatever you choose. So maybe just do not implement some scenarios at all if you are not comfortable with that. So test automation requires skills, and at the end of the day, automation is software development. Either you write code or not write any code, it is software development. You will have to make your hands dirty at some point and learn about some technical things. So it's not just clicking with the mouse and entering text. But there is no magic in test automation. So this is very interesting and complex field, and you can start this journey right today together with Inflectra. So we are encouraging you to hop on our bus and get on a wonderful tool with our company. So, demo time. I'm going to create a data-driven automated test with rupees. So let me switch to the virtual machine. Okay, here is rupees. And now I'm going to create a new test. I need to provide a name for this test. And in rupees, you can go either with manual testing or you can go with automated testing. So I'm going to create an automated test. So I will choose a browser for recording. And I will use visual representation of recorded steps in rupees. So here is the application that I will be testing. This is a sample library information system. In rupees, I start recording. So I'm going to record a few steps in this application. So I click on the login button in the top right corner. And rupees intercepts my keyboard and mouse and records my interactions. So let's now enter username, password, and click login. And now I want to verify that the login was successful. For this, I'm going to verify that there is a button with text logout displayed on this button. Now I click logout and verify that logout was successful, and now I have a button with login text. Okay, finishing recording and adding steps to my test. So this is the scripted automated test. So every step is clearly defined, as you can see. So for every step, we have object on which to act, so element in the application, and we have an action to perform over this object. And if there is some data that we need for some step, for example, like for step 4 or 5, we can specify this data in the param value column. So here we provide the username and password. Okay, so we now have a test recorded. Let's check that it can be executed successfully. Now replace the steps and perform centering of the data and verification of the state of the application. Okay, so we have automated test. And now let's see how to make this test data driven. For example, if you want to check that we can log in with different usernames and password, can just define the table of data and use it. So I'm going to add a few more rows at the beginning of my test. And now I will define the table. Let's name it logins. In this table, I just need 2 columns. So I will delete columns that I don't need and will rename the columns. So username, password, librarian. This is what I used during recording. And let's also add one more line here. There is user borrower in the system. Okay. And what I need to do here is I just need to parameterize my test. So I define a table, but on lines 14 and 15, I have my values hard-coded. So I just change the type of the parameter to the name of the table I just created and select the column from which to get the value. And the same for the password. So if we will execute this test right away, it will just use the first line from here. What if you want to check a specific username and password while we are working on this test case? I can just write a special keyword, this, on the line that I want to use. And now if I will execute my test, it will use data from the second row of my table. So now Rapis uses borrower, performs logout, and we have the report all green. Okay, so what if you want to check every line in this table? So I will delete this keyword. And now I will just wrap the steps that I want to repeat for every row in my table into a loop. So I select these rows and choose wrap selection into loop. And here I choose that I will be looping through my table. Here is the name of my table. Okay, so now I have a loop that will just repeat all the steps for every row of the table that I created. So let's execute it. So first Rapis will use librarian, and then it should use borrower from my table. This is the power of data-driven testing. So I recorded steps with one set of data, and then I can execute with different usernames and passwords and verify results. Okay, so let's switch back to presentation. All right. So on this slide, we gathered some references that you may consider interesting. So these are references to some very well-known books on testing and some websites with useful information about exploratory testing and test automation. So if you want to get more information on the topic, I encourage you to look at those books. And our next webinar in this series will be devoted to the question, is application ready for test automation? So even if automation testing is a decided step in your company, so there are many common mistakes that are done from the very beginning. So some people try to do automation with tools they have, and some try to record very first scenario without prior planning, and some try to evaluate tools and compare features of those tools. So in this webinar, we are going to talk about how and where to start and where to begin test automation. The presenter of this webinar will be Alexey Grinevich. He is an automation expert at Inflectra, and he has a lot of experience with different types and with different applications.